very good evening and welcome to Vedantu daily sessions. So guys, this is the last video for the chapter Matter in Our Surroundings. We were talking about matter in our surroundings from past 4 videos. Today is the 5th video. So we have covered all those important points about the physical states of matter, interconversion of states of matter, evaporation and all of that. So in today's video also I'm going to talk about evaporation, but then applications of evaporation. So there are some questions based on applications which keep repeatedly asked in exams. So we'll be talking about those questions today. Well, after this, we'll be talking about next chapter, that is chapter number 2. You can let me know the topics that you want to learn with me. In case you have missed out all my previous videos and this is the very first time that you're looking at my face, you're listening to Dr. Nazma Sheikh and I teach chemistry. And today we are going to talk about applications of evaporation. So these applications of evaporation, in spite of making a running notes, in spite of writing down the notes, do something. Listen to this, just sit back and listen to this, okay? Because this is a lot of theory than you writing down something, okay? Well, a quick recap of what's evaporation and how does it differ from boiling. You see the images already on the screen. So the second image is also a beaker. Let me move myself here. Yeah, the second image is a beaker with particles being evaporated. So the first beaker is representing evaporation. Just observe the molecules which are participating in evaporation. Only the top layer molecules absorb energy from the surroundings, from atmosphere, and they get evaporated or they get converted into the vapor physical state. That's what happens in evaporation. Evaporation is a process which happens at room temperature. You don't need to boil something to its boiling point in order to turn it into vapor. That's what is the main principle of evaporation. Like water cycle is an example of evaporation. The water from the surface water bodies gets evaporated due to sunlight, etc., right? And in the same way, there are so many other examples of evaporation also. The example that we have discussed, I hope you remember, evaporation of water from wet clothes. We have taken one example that you have to dry your school uniform and how do you do it, right? That's also an evaporation. Some water droplets spilled on your table and you come back after a few hours and see they do not exist there. So that also is due to evaporation. Similarly, there are so many other ways that evaporation is very much useful to us. So I can say those are all the applications of evaporation, the uses of evaporation for human life. Yeah. So application number 1 that we are going to talk about is something related to sweat. Yeah. Take a look at this. Whatever the text being covered behind my webcam is sweat gland. Okay. I hope that's not very important. So it's cool. How is evaporation related to sweat? Why are we talking about sweat? Listen to this context first. When you studied the chapter synthetic fibers and plastics in class 8 and before that synthetic fibers, about fibers and all of that, you have studied for so many times that during summer cotton clothes are preferred, during winter woolen clothes are preferred, right? This is what you have studied. And you know the reasons also. Do you remember? Cotton clothes are preferred in summer because cotton fibers have good absorption capacity. So the sweat secreted by the body is absorbed immediately by cotton fibers so that you will not have that irritation on the skin. That's what you studied there. And now whatever we are going to learn right now with this video is something next to that. Like it's a continuation of that. Yes, cotton fibers have good absorption skills and they absorb the sweat produced by your skin or the sweat glands easily, comforting you. But then there is one other advantage of wearing cotton fibers, or there is one other thing that happens when your body sweats, and that is you'll start finding your skin getting cooler. When you sweat, maybe when you work out, after you sweat, try to touch your arm and see what is the temperature of the skin. You will find it cooler than usual. So why exactly is your skin or body getting cooler? To some extent at least after sweating or when you sweat. What exactly happens over there? That cooling effect is caused due to evaporation of sweat from the skin. Does it mean evaporation causes cooling effect? Yes, absolutely. It means evaporation causes cooling effect. Whenever you have some evaporation happening from a surface, the surface gets cooler. Means what? I'll take one more example. Do you know nail polish remover? If you are a boy and you have not used it, maybe your sister, sibling, or mom, aunt, somebody at home would be having nail polish remover. Take a little choda sa sample or a few drops of nail polish remover, the liquid, into your palm. Okay? And just wait for it to get evaporated. It gets evaporated in around 1 to 2 minutes of time. And when it is getting evaporated, you observe the temperature. You observe the feeling, the sensation on the skin. You will be feeling that cold behavior, or you'll be sensing that cold at that place which is in touch with the drop of nail polish remover. So as that gets evaporated completely, then the temperature comes back to normal. But during evaporation, you will have that cooling effect. That's another proof that evaporation causes cooling effect. Now let's understand, why does evaporation cause cooling effect? Or how does this cause cooling effect? Just assume that this is the surface and these are the drops of whatever nail polish remover getting evaporated. How are they getting evaporated? First of all, what is happening when they are getting evaporated? Liquid to gaseous physical state, right? Are you all able to follow? You are, right? These topics are very important topics, okay? And you need to know the logics behind this topic so that you don't get confused later. Done? So, right. Evaporation is a process in which a liquid gets converted into gas by absorbing energy from the surroundings. Okay, so for these droplets to get evaporated, the energy is absorbed, one from the surroundings, also from your palm. So this is the surface of your palm, okay, surface of your hand. So they absorb energy from your body surface also, because your body surface has 37 degrees Celsius of temperature, isn't it? That means it has ample of energy to provide it to these water droplets. So during evaporation, along with taking energy from the surroundings, these droplets are taking energy from your skin, from your body. As a result of this, what happens? At this particular point, your body will be losing energy. Because your body is losing energy, you'll start finding cooler. Whenever your body is giving energy to something, you'll find it cool. If your body is taking energy from something, you'll find it hot. Okay. For example, if you're touching a metal at higher temperature, a hot metal, not very hot, but yeah, a hotter metal, if you're finding it hotter, that means the metal is transferring energy to your body. Your body is getting that energy. Okay. So evaporation causes cooling effect, especially onto skin. It causes cooling effect because the process of evaporation is endothermic. The process of evaporation is endothermic, which means it intakes energy from surroundings. It takes energy from the surface that it is in touch with. If you apply the same concept to sweating, whenever your body sweats, the sweat droplets need to get evaporated, and for the process of evaporation, they take energy from your skin, from your body. That means your body gets cooler during evaporation of sweat, right? So now, let's consolidate everything and talk about it. During summer, cotton clothes are preferred because cotton clothes will cause absorption of sweat, and of course, they will comfort you. Because the sweat is getting absorbed easily, it gets evaporated easily, and evaporation process causes cooling effect. So if you wear cotton clothes in summer, one, you will have that cooling effect of evaporation, and moreover, you'll also have comfort because cotton absorbs sweat easily and immediately, right? So evaporation causes cooling effect due to endothermic behavior. I hope that's clear. This is the first application of evaporation. Evaporation causing cooling effect to the body is very much needed, right? So now, second application of evaporation. This is a very important question. It's like often seen in exams. How does a hot dessert cooler cools the air effectively on a hot summer day than a humid rainy day? If you talk about a water cooler, let me simplify this. If you talk about a water cooler, you know how water coolers work, right? We put in water and then we turn it on. The air passes through the streams of water. That's how we get cooler air. So now if you consider the same water cooler, the functionality of water cooler is the best on a hot summer day. It gives you very fresh, cool, refreshing breeze on a hot summer day than on a humid, rainy day. What is the difference? Like, why is it more efficient on hot summer day than a humid, rainy day is what we are going to discuss now. Okay, you just observe this principle. This is picked up from web, but it is helpful. So if you just look at the functionality of a water cooler or air cooler, whatever you say it as, this is the fan. And now this is the water tank, or maybe the deposition of water. We fill in water over here. And once you turn on the motor, the water is streamlined all across these pads. Okay. And now when water is being streamed all across these pads, the air is also absorbed. So the air is directly flowing through the streams of water like this. Correct? And now the air which enters the water cooler need not be cooler. It's a hot air. Now, the air which comes out of water cooler after passing through these pads of water is refreshing and cold. How is this happening? That's what we are going to learn right now. Okay. So now the hot air has, of course, it has more kinetic energy. Of course, it has more temperature. That means this particular hot air, when it is passing through the streams of water, it is losing its temperature. Okay. So it is giving away its temperature. To whom? To the water. Now the hot air coming in touch with the water particles which have low temperature, the hot air transfers its heat energy to the water and it passes through the water streams. So the water streams are absorbing energy and the air which passes through the water stream is now no more hot because it already gave its hotness, temperature to the water pads, right? Are you all able to follow? Yes, that's great. So now what is happening? The temperature of air is being reduced. So the air which comes out of these water streams is cool and refreshing. Okay. Now how is this related to a hot summer day or a humid rainy day or whatever? How is this affecting the temperature? How is temperature of the atmosphere affecting this process? If it is hot summer day, do you think the temperature of the hot air is going to be still hotter? Because it's hot outside, the air also will be hot enough. Now, hot air means it has more temperature. More temperature the air has, more is the temperature that it transfers to the water. More temperature transferred to water, more is the cooling effect. That's what the statement says. But how is the question? When the hot air is transferring its energy to the water streams, you know what does the water particles do? The water particles will absorb it and will get evaporated. If you have noticed, you have to fill in water into the water cooler every day. You fill it once a year, it works. No, that's not the case. You got to fill it every day. That means what's happening to this water every day? It's getting evaporated. That means the heat or the temperature given by hot air to the water stream is used in the process of evaporation. That means more is the temperature given by hot air, more should be evaporation. Correct? Yes, that's what happens. More is the temperature, more is evaporation. And more is evaporation, more is cooling effect, because evaporation causes what? Evaporation causes cooling effect, isn't it? So on a hot summer day, because the atmospheric temperature is high, the air also will be hotter enough. So it can transfer more energy to the water streams, and that more energy can cause more evaporation, and that more evaporation causes more cooling effect. This is the sequence. But then on a rainy day or a humid day, the temperature is relatively lesser. So less temperature or less heat energy is transferred to the water streams. Less is evaporation, less is the cooling effect caused. Are we clear? So this is all like sequential, interlinked to each other. Remember something. These all applications that you are talking about are related to the rate of evaporation and temperature. More is the hotter atmosphere, more is evaporation, more is cooling effect. That's what I mean to say through these applications. Alright, so what did we do so far? We are just trying to learn the applications of evaporation. One application is in the real life, that you wear cotton clothes and the evaporation causes cooling effect. Evaporation of sweat causes cooling effect of the body. That's one application. The second one is how does a desert cooler works well on a hot summer day than any other humid rainy day. Are we clear? I hope you have understood, because than the evaporation of sweat and all of that, this particular question is super important. And not only these applications, evaporation has so many other applications. Like water cycle is application of evaporation. It is happening due to evaporation, and you know how important water cycle is, right? It balances the water levels in the ground, in the atmosphere, it gives rains, thereby promotes agriculture, etc., etc. In the same way, evaporation also has super awesome applications, like the water in the earthen pot, that mud pot you might have seen being used in olden days, but even these days many people use it. When you keep water in the mud pot, it gets cooler after a while. Why? Because hotter water particles get evaporated, they escape out of the pores of the mud pot or the earthen pot, and leaving the cooler particles behind. So even that is evaporation. You will be for example, if you are drinking a hot cup of tea and you just want to finish it quickly, so you put it into saucer and you just blow some air over it, like, correct? Why do you do so? Because it causes evaporation. It causes evaporation of those tea or maybe coffee particles at a speed, increased speed. More is the wind speed, more is evaporation. So these all are the techniques of evaporation that unknowingly we are using in real life. These all are important in exam point of view. All right, you need to know each and every example that I said today in the video. Done? As you know, these videos are only important topics, but not everything. So whatever is covered in these videos, at least that you got to be extremely perfected, right? So with this, let us conclude the chapter number 1, matter in our surroundings. We have covered all those important points which are needed, but of course there are so many points else which we did not cover, but they are also enough important. Make sure you learn them. Make sure you let me know in the comment section if you have any questions or any doubts. And the next video will be starting with the fresh chapter. Probably chapter number 2 will start, will move in the sequence. Okay. So now in that chapter, if you have anything in particular to be learned, do let me know. I'll try to make the video on the same. Done. So I hope these videos are helping you. If they are helping you, make sure you subscribe to Vedantu so that you get to watch or you get the notification of rest of the videos being updated. Done. So I'll see you all in the next video. Until then, bye bye everyone.